Okay, so the next step after we've turned on our light is to add another component. And we're going to jump into the world of sensors. So we're going to be using a flex sensor, which you see right here. And the way a flex sensor works is that it is actually a variable resistor. It acts like this resistor, except that it sends a variety of values depending on how much you bend it and how little you bend it. So it controls the flow of electricity depending on how much you bend or how little you bend. So this flex sensor actually has a polarity. So one side is the power side and one side is the ground side. The side connected to all the squares, that's going to be the power side. And the straight line section, which is that section, is going to connect to the ground section. And there are two ways in which a variable resistor works. If we connect, similar to the light bulb, if we position this resistor that we're going to be using, which is a 10K ohm resistor for this flex sensor. So if we position this sensor so that this resistor comes in between the power side, and the board itself is this resistor, what will happen is if there is no flexing, the light will be totally off. Let's say that this sensor is in between this resistor and the board. It means that if there is no bending, then the most amount of electricity will flow through. But once you bend it, then there will be no electricity flowing through, or very little. What we'll be doing today is we're going to shift it around so that this resistor is in between the flex sensor and the board. Which means that the more that we bend, the more the light will turn on. Similar setup for our LED, in which our LED will be connected to our pin 3, our ground to this main section of ground, and then connect it to the LED. Awesome. Then we're going to take our flex sensor, as you can see, bends. And we're just going to connect it down here. Maybe we'll connect it to between 15 and 16. Why not? Okay, so remember what we had mentioned before? We're going to put this resistor, we're going to use this side. This resistor between our power source, or our pin, and the sensor itself. Awesome. I'm going to connect this to our ground. Wondrous. Okay. Let's connect. Let's see. So we're gonna connect this sensor to a 0. Make sure. Okay. All right, great. So we've got everything wired up. Okay, so now let's get on over to the code to code this flex sensor. So let's keep the same sketch that we had pulled up for our LED pin that was connected to pin number 3. And we're just going to build off of that and continue working on it. We can close out our blink LED, and we'll just work on this one. Okay, let's get started. Okay, so up here at the top, we already have our constant integer of our LED pin labeled as number 3. So our LED is labeled as LED pin, and we know that it's connected to pin number 3 in the digital side. Okay, so let's do the same thing for our flex sensor. So our constant integer flex pin will be equal to A0, boop, and then we're going to end it with a semicolon. Then we're going to have another section that we're going to need to establish, which are for our variables. As in, we need to store the information that is coming out of the flex sensor. We need to store it. So we need to make sure that the code knows from the very beginning, the top of the page, it needs to know that it needs to store this before any code is written. Great. So let's write our integer value, and oops, almost forgot, gotta end our sentences with our semicolon. We're gonna write, this is going to save our analog value. Great. Let's just write notes at the top here too. Why not? Just to continue to keep ourselves organized. LED pin is connected to pin 3. Flex sensor to pin A. Awesome. Okay, let's get to the pin setup. The void setup. It'll stay the same at the beginning. We still need our LED pin to be an output. So we're going to keep that the same. But we're just going to add an extra section. Okay. And we're going to be communicating via serial communication. Okay, what is serial communication? Essentially, it means that all of the values that we're going to be storing from the flex sensor, when we flex it a little bit, it'll send a little bit of a value. If you remember, our analog values range from 0 to 1023. 0 being 0 volts, 1023 being 5 volts. And we need to see the range of these values, and the place that we see the range of these values is through serial communication. And I'll show you exactly what that is in a moment, but first we're going to write the code. We need Arduino to know that it needs to record it somewhere, and we need to be able to see it somewhere. So we're going to start off by writing serial. I think it's, oopsies, capital S, serial, lowercase b, begin. And we're going to put 9600, which is kind of, in my mind, it functions like the channel, that it's like a radio signal almost. And 9600 happens to be the channel that the signal is coming in on. That might not be correct, but that's the way that I have understood it. Okay. And we'll just write begin serial communication. Serial communication is going to be your best friend in this workshop. Okay, cool. That's it. That's all we got to do for void setup. Did I do this wrong? Well, we're going to find out. Okay. Now, let's go to our void loop section. This is going to be a little bit different than our previous section. So first, we need to identify the values that we had initially set at the beginning of our code that we needed to save analog value. Right now, the code doesn't know from where. Okay, we know that we need to save analog value, but we just don't know where. From where? So it needs to check something, but we just don't know what it's supposed to be checking. So this is where we write what it's supposed to be checking. So our value is going to be equal to, and it's going to read the analog section of the flex pin, and this is going to tell, and this is essentially telling the Arduino to read and save the value of the flex sensor. Now let's look at it a little bit closer, just so we get a sense of what it's doing. So again, just so that it makes sense, this value is coming from here. the code, you know, has already started by saying we need to store a value, and it has to be an analog value. And we have to be, and when we're creating our loop of code, that means this is going to be running and stopping and running and stopping and running and stopping. And so what we're asking the code to do is to read this value from the flex pin. Okay, so we'll move on to the next section, which is, and then we're going to take that information, that what we've just read, the value that we've just read, and we're going to serial print on a singular line the value of what we've just gotten, right? So we'll be able to see in this serial monitor, which I'll pull up in just a moment once we start running the code, that each line will have the value that's been read from the flex pin. Cool. And let's just put boop, boop, print value. Sorry, my dog is huffing and puffing in the background. Okay, now the next thing that we have to do is, oops, I misspelled print, of course. The next thing that we got to do is we have to map the values. I don't know if you remember from the last section, but we talked about the differences between analog output and the digital PWM output, and how the digital PWMs, or the pins with the little tildes next to them, mimic a range of values similar to what analog pins do, which is they transmit and receive a range of values. And so we are going to map the values of an analog sensor to that of a digital sensor, or the PWM. So we're gonna do that here. So we have to be able to translate. Essentially, we're doing a translation of between metrics, between measurements, different kinds of ways of measuring. So we're mapping it out. So we use the map function. Map. Oops, I'm sorry. We're gonna use value. Our value that we've received from the flex pin will be mapped onto value. Okay, so we're going to map the value. And the first integer we're going to use is 700. Next one will be 900. And then the next one will be 0 to 255. So essentially what we're doing is, so we've got value map value. 700 will be equal to the 0, and 900 will be equal to the 255. And then the next thing we're going to do is we're going to analog write our LED pin as the value that we received from the flex sensor. And the reason why we use analog write instead of digital write is because now we've transitioned our LED pin to function like an analog device. It is no longer reading like a digital write. So it isn't functioning, it isn't working the way that digital write would function, which is as either high or low. Now it's working like an analog device that receives a range of values. So let's delete all this because we no longer need it. All right, analog write to our LED pin the value that is received from the flex sensor. And then we're going to delay a really small delay of just 100 milliseconds between the information that's being sent from the flex sensor to the LED. Okay, so we've plugged it in. Make sure that it is, again, the same board with the same, okay, yeah, it's connected to the same port. So make sure all of this is verified, that all of this is, we haven't made any mistakes in our code, we haven't missed anything. we missed something. Serial dot begin. Serial, oh, this might be capital. That's it. So I missed a capital, I missed a period. Happens to the best of us all the time. So, okay, so this works. Great. Well, I mean, at least it's verified. Let's upload it to our board. And now let's take a look. All right, so now let's try bending it. The more that I bend, the more that it turns on. Oh, you do. Awesome. Bend, it turns on. Bend, it turns on. Bend, it turns on, it turns off. And right now, the way that I've coded it is between values 700 and 900. 700 is off, 900 turns it on. But you can always change this. Now we're going to go back to our Arduino section here, our Arduino IDE, and we're going to pull up serial monitor to see exactly what's happening. Okay, I've got it set here to 9600, so it's on the correct channel. You notice on the left hand side, each line is being printed with its current value that's, you know, pumping into the serial port. So we know that right now the flex sensor is at 529 at its rest state. If I bend it here, if I bend it, you notice on the light, left, it's turning from 700, getting closer up, 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 up. Doesn't quite ever get to 900, but the more that I bend it, the more that it gets past the number 700, it's turning the LED on a little bit. Let's see, let's see how I can get it to, can I get it to 900? Let's see. Not quite. The more that I bend it, the more that it turns on. And I may have my values off a little bit, but you kind of get the picture. Let's see what happens if we move it around a little bit. Let's go like 0. We'll set this to 0 and 900. What happens there? Then it'll just be like forever on. But let's just like see what happens. We've uploaded it. Now it's like kind of on. It barely turned up. It's a little bit more responsive, huh? A little bit more sensitive. If we want it to be a little bit less sensitive, we'll go back and change it to 700. See what happens. If this has even shifted anything. It's kind of the same. Okay. That's that. So now we got a sense of our serial monitor, what information is kind of coming into the program. 540 is basically the rest state. And the most I can bend it to, it seems like goes up to about almost 800. Doesn't ever quite get to 900. Anyway, you can play around with it to get like a little bit more finesse to what it is that you're doing. But know that it's mapping the values from analog to PWM, which is analog to digital, and then the digital is then being, uploaded to the LED, or it's being transmitted to the LED to then turn on at a range. It isn't just on or off. It's actually, there's a little bit of a range. See, this is like slightly on, this is a little bit more on, so on and so forth. So there's that code. Awesome, we did it.